So in Unit 36, we have studied how to measure the reaction rate. Now in Unit 37, so we are going to study why some reaction will get faster and some reaction will get slower. Is there any reason behind to galvanize the reaction rate? Yes. Before we start our discussion, let me introduce a scientific theory, or something called collision theory. Well, collision theory mentioned that in order to have a reaction, the reactant should have a effective collision. Now, how can we interpret the term effective? Is when two reactants collide with each other, they should have enough kinetic energy first. That means if the reactant collide each other with not enough speed, they are moving too slow. So sorry to say, they cannot start a reaction. So how much energy is needed? We have a special term called activation energy, which is the minimum amount of energy that required to start a reaction. Without that, sorry, we don't have any reaction. This is point 1 for ineffective collision. And here we introduce an important graph called energy profile. Now, everyone should pay attention. You should draw it by yourself. Now, here shows this one is our reactant. The x-axis is called reaction coordinate because it is suitable for reactant and product. That's it. For y-axis is potential energy. Sometimes we will call energy alone. Now, after the reactant got enough energy, we call them activation energy, EA. It will go to uphills to something called activated complex, or sometimes we call it transition state. Well, at that point, they have two choices. Either move forward to the product or go backward to the reactant. And if this is an exothermic reaction, so you are familiar with that already. If this is an exothermic reaction, the product's position should be lower than that of reactant. And the difference is our old friend again, enthalpy change of reaction. So you can see actually energy profile also coherence with what you have learned in Unit 35, the Hess's law. You can see the delta H actually have no relationship on the reaction path. I don't care about your activation energy or not. I only care about the position difference between the reactant and product, right? Yes. So this is point 1 for the effective collision. You should have activation energy. You should move fast enough to start a reaction. The second point is not every collision, even they move fast enough, they will not have reaction if they collide in a not suitable orientation. Well, here I use a covalent bond as an example. Remember, HCl, okay? Well, this is HCl. So how it forms? The basic idea is the chlorine atom and hydrogen atom collide with each other, right? Now, but only in this way, the hydrogen approach can start a reaction. if the hydrogen approach in this three way, or from top or from bottom, oh sorry, they cannot form new covalent bond. Only one single direction can start a reaction. That's why when we discuss covalent bond in grade 9, we have a very special term for that. It's called directional force. That's the point, because in order to build new covalent bond, direction or orientation really get matter. This do not appear in ionic bond, because ionic bond is just the attraction between opposite charge, so every direction are welcome. So let us write it down. For the effective collision, they should fulfill two criteria. First is they have kinetic energy greater or equal than the activation energy. We call EA. The second one is they should collide each other in a correct orientation. All these 2 points will result in a effective collision. And from now, you may understand why the organic reaction usually gets slow. We need heat, we need catalyst, we need reflux. Why? Because organic reaction, most of them involve breaking or forming covalent bond, which is a directional force, and this will slow down the process. All right, so the checkpoint, please do it, and I will check it later. And now we come to the core in this unit. We study 4 factors affect the reaction rate. Now, if you study carefully, for the effective collision is just like playing a dice. Playing a dice is when you, for example, when you got 0.6, then you can go further. Okay, if you got other points, no. So how can you increase your chance of getting 0.6 in a dice? Now here shows. The first one is the concentration. Now, if you got higher concentration, you got higher chance to collide with each other, right? Alright, so for example, if you got 10% success, but first case is you got 10 trial, so you will get 1 success. But if you got 1,000 trial, then you will have 100 success case, right? So try more, will get more success case. Same to the reaction. If you got higher concentration, then the collision frequency will also increase, right? And then with the same probability, because your collision frequency increase, so the number of effective collision also increase, right? So finally, the rate increase. But please keep in mind, you have collide more frequency. It doesn't mean you move faster. It doesn't mean you move faster. You only get more chance, right? And that, so just keep it in mind first. I will tell you later why this sentence is so important. The chance of success will not increase, will not decrease, even though you get higher concentration. So you can see, well, in this case, HCl is in excess, right? So with higher concentration, the reaction will end earlier. The less concentrated one will last for longer, but they get same amount of product. That is the point, right? So how can we know that the reaction ends earlier in the concentrated one? Yes, just measure the slope, right? The slope means reaction rate. Hope you still remember. So the reaction rate for 1 m HCl is higher. Well, this is easy to understand, right? But keep in mind, more concentrate doesn't mean move faster. Okay? Okay, again, please do it. All these checkpoints are very, very, very important in your exam, okay? Because they always, not usually, they always appear in your exam. All right? Well, the second one is the surface area. So you can get the same chance, right? When you get more surface area, that means you get, again, the collision frequency also increase, right? Again, the number of effective collision also increase, therefore the rate increase. This is easy for you to understand because with larger surface area, that means you can trial in different pace. You can start the reaction in different pace. Of course, the reaction is faster, right? So usually we compare the solid, okay, yes, this is for solid only, right? For liquid and gas, it means it is meaningless to discuss the surface area. So powder versus lump. Lump means large solid, okay? Okay, skip factor 3 first. We go to the, again, in surface area, please again write down. Not means move faster. Well, larger surface area not means you move faster, right? You just try more. Right. Factor 4, okay, is important because this is something new for you, is the presence of catalyst. So if you study biology, so enzyme is certain type of catalyst. But first, let me tell you the truth is catalyst actually can be positive and negative. Yes, unless we specify. Otherwise, we will consider everything as positive. True. So what is meant by positive catalyst is increase the reaction rate. Okay, positive catalyst can increase the reaction rate. So you can expect, what about the negative catalyst? Yes, slow down the rate, right? In biology, you got another term for negative catalyst, is called inhibitor. Okay, so but how how can the catalyst increase the reaction rate? Please memorize this. It provides another reaction path with lower activation energy. So if you have no idea what I'm talking about, so see in this way. Right? This is reactant to product. Alright, to the highest point, this is activation energy. Right? So in order to have a reaction, you should have fast enough speed to overcome the activation energy. Sometimes we call them energy barrier. But with use of catalyst, actually you are doing another reaction but with the same product. So this one is with catalyst. So if you still don't understand, try to think in a climbing the mountain. Okay, the red one is from point R to point P, you need to pass through a high mountain, which is very demanding, right? But with tunnel, the blue one, I take a tunnel for that. Life become easier with tunnel, right? If life become easier, that means the new activation energy is lower, or I can say more people can overcome the mountain now, and more people can pass through the mountain to the product side like this. That is what I mean. Provide another reaction path with lower activation energy. Please memorize this sentence. Okay? And as a result, higher portion of reactant got enough energy to overcome the activation energy, right? And hence reaction rate increase. Alright, but again, it doesn't mean you move faster. Just imagine in your examination, the passing mark is 40 marks. Okay? Now, the use of catalyst means I lower the passing mark from 40 to 20 marks. Yes, more and more students got passed in their examination, right? But it doesn't mean you got smarter or you got higher mark. You passed the exam because I lower the passing mark. Well, this is the effect of catalyst. Don't worry, the catalyst will regenerate after reaction, so no chemical change permanently on it. Okay? At certain point, the catalyst may be consumed, but don't worry, in next step, it will form again. This is catalyst. So here, we use the composition of hydrogen peroxide as example. We measure the change of pressure with pressure sensor and data logger. Step 1 with Dowmac catalyst. Step 2 with catalyst. So the result will be like this. With catalyst, wow, the reaction faster. Okay, so what about the first experiment here? So here is slower. And you can see actually use catalyst results in faster reaction, very good, but not higher yield. Because your yield depends on how much reactant you input, right? Without catalyst, yes, the reaction will slower, but eventually, if you have enough time, then you will receive the same amount of product. So please keep this in mind. Okay? So, yes, the first catalyst you have come across is the catalytic converter, right? Yes, you use palladium to change the harmful gas CO and NO into harmless one, and those unburned hydrocarbon into CO2 and water, which is harmless. Very good. But now I need you to study one more catalyst seriously. Is Haber process. This is the superstar in our chemistry syllabus in DSE, the Haber process. Haber is a scientist, okay? So you will see more about him in the later section of this notes. Well, his greatest development is he used a cheap metal iron to turn nitrogen and hydrogen into ammonia. Well, the ammonia means you can go further to form fertilizer. Okay, as I mentioned in the lessons, about 40% of population on our Earth is fed by fertilizer produced by Haber. Okay, thank you. Say thank you to him. Is produce of ammonia. This is, as I say, this is a superstar in our syllabus. And another reaction is called contact process. We use palladium to form SO3. Well, normally SO3 do not appear in our atmosphere or in our room temperature, and pressure. But with the catalyst, we can form SO3. After dissolve SO3 into water, we can form sulfuric acid. So keep in mind that sulfuric acid is not dissolved SO2 but SO3. But sorry to say, we don't have too much SO3 in our daily environment. So thanks to the contact process. Right. Everything not means move faster. And here come to the final and most difficult part in this unit is the temperature factor. Wow, this is horrible. Because when temperature increase, actually you are changing two parameters. The first one is when temperature increase, you move faster, right? When you move faster, the collision frequency will increase. So you can expect the number of effective collision also increase. Very straightforward, right? But when the temperature increase, the second factor is you have move faster. That means higher or larger portion of reactant got energy greater than the activation energy. So what is that mean? That means originally your reactant is here, but with higher temperature your reactant is here. So you can see the new activation energy is smaller than the old one, right? So of course more people can start their reaction. So that's why I say the temperature factor is horrible, because not only change the collision frequency but also change the energy, the kinetic energy. Well, yes, move faster. So give you a simple idea is only small change in temperature can double the reaction rate. So for this unit 37, please complete every single checkpoint. So I will not go through the checkpoint with you now because it will be too time consuming. I will do it in the second video for that, okay? But all 4 factors, please understand and memorize. Make sure you can write them out by your own words. Okay, if you cannot, please memorize what I have mentioned in the notes. Okay, so we see you in next video. Okay, bye bye.